concept of ozone will be used in the blockchain as well as in artificial intelligence. Okay.
Finding difficulty in this blockchain one part. Ozone
Yes.
is, but that blockchain I'm still unable to understand.
Yes, blockchain is a bit difficult. Okay. You have to cover it from the perspective of the UPSC, and you have to learn a few things about the blockchain. That blockchain is basically digital information, okay, stored in the forms of blocks, and that digital information, it cannot be, okay, tampered with. We cannot modify it later on. So we have the immutable digital information, and that technology is known as blockchain. उसका फायदा यही है कि एक बार डेटा आपने डिजिटली स्टोर किया तो फिर उस डेटा को मॉडिफाई नहीं किया जा सकता। सो ब्लॉकचेन टेक्नोलॉजी का क्रक्स यही है, एंड उसके बहुत सारे यूजेस हैं, तो वो हमने देखे थे। अगर सिंपल भाषा में किसी को बताना हो कि ब्लॉकचेन टेक्नोलॉजी क्या है, तो ब्लॉकचेन टेक्नोलॉजी की यूज से आपकी जो डिजिटल इंफॉर्मेशन है उसको फिर कोई मॉडिफाई नहीं कर पाएगा, उसके साथ फोर्जरी नहीं हो सकती है, लेटर ऑन उसको मॉडिफाई नहीं कर सकते हैं। तो ये इस तरह की टेक्नोलॉजी है, और ये प्रोग्रामर्स अचीव कैसे कर सकते हैं वो हमारे डोमेन से बाहर है। ओके,
थैंक यू,
वेलकम इंडिया। Don't worry, Nikhil, we are taking a top class on the blockchain. Okay, सी वो टेक्नोलॉजी को अचीव कैसे करना है वो डोमेन फिर हो जाता है कंप्यूटर इंजीनियर्स का। ओके, लेकिन हमको ये पता होना चाहिए कि टेक्नोलॉजी का पर्पस क्या है, उससे हम अचीव क्या करते हैं। ओके, अगर ब्लॉकचेन में हम डेटा को स्टोर करेंगे देन इट विल बी हैक प्रूफ, वी कैन नॉट चेंज इट लेटर ऑन। सो एक बार जो फीड कर दिया वो डेटा इंटीग्रिटी मेंटेन रहे। आई होप ये वाली चीज समझ में आ रही है जो मैं बोल रहा हूँ। Okay, thank you, Vipul. So why do we study these gravity waves? Okay, why do we study these gravity waves? There is a reason for it, because we are exploring the universe, and we are also exploring some philosophical questions, that why do we exist? Do you have answer to this question, why do we exist? Okay, in the exploration of this question, the religion was invented. Okay, religion was basically invented to answer some of the toughest philosophical questions, and science is approaching this question in a very different manner. Is it clear to you? So by detecting the gravitational waves, we are observing that part of the universe which was otherwise invisible to us. Is it clear? We are observing even those events in the universe which were otherwise invisible to us. तो अब तक स्पेस टाइम एंड द कर्वेचर ऑफ स्पेस टाइम, इन आइडियाज में किसी को कोई प्रॉब्लम? एब्जॉर्ब होने में थोड़ा टाइम लगता है, क्योंकि काफी these were very radical ideas proposed by Albert Einstein, and it take the scientific community to absorb, okay, some time to absorb these ideas. So space time curvature में किसी को कोई प्रॉब्लम? क्या हुआ, आवाज नहीं आ रही क्या? Please be attentive. Okay, so we are studying these gravity waves to detect those events which, okay, from which no observable light originates, like the black holes. And by studying these gravitational waves, we can learn more about the neutron stars, and I will tell you what these neutron stars are. Okay, so we can know a lot more things about the neutron stars, because these neutron stars We do not have much information about these, but the collision of the neutron stars, it can produce the gravitational waves. And the astronomers can now see into the deep space through the gravitational wave astronomy. Otherwise, we were observing only the light that was emitted from the atoms. Okay, the emissions originating from the gases, okay, the emissions that are originating from the sun. So we were studying all these only in the, these are all electromagnetic radiation. So we have all the information about the structure of universe by the study of electromagnetic radiation. But now we have one more option. The gravitational wave is now a new addition to this category. Okay, to this category of inspecting the universe. Earlier we were inspecting using the electromagnetic radiation. Now we can inspect using the gravitational waves. Okay, and also we have some of the physical questions, philosophical questions, sorry. Okay, so understanding the origin of our planet and understanding even our origin. Okay, so that is why we are understanding the whole cosmos. Okay, we are understanding the whole cosmos to know more about ourselves. Okay, what is our purpose and why do we exist? Okay, and what is our purpose? तो रिलीजन, ये तो सब एग्री करते हो ना कि रिलीजन का जो ओरिजिन है, इट इज बिकॉज ऑफ सम ऑफ द टफ क्वेश्चंस जिनके आंसर ह्यूमैनिटी के पास नहीं थे, उनके आंसर्स देने के लिए लोगों ने गॉड की इन्वेंशन की. Isn't it? Do you agree or not? See, no religion in the world, okay, no religion in the world, be it any religion, they have predicted the gravitational waves. Okay, no religion in the world, they knew about the black holes, because these are innovations of mind, the religion, mythology, existence of God, philosophy. Okay, so it means there was some limitation in our thinking. With science, we can move much ahead. The approach of the science and the approach of the religion to the mystery of the universe, they are very different. सब एग्री करते हैं ना? किसी भी रिलीजियस स्क्रिप्चर्स में ग्रेविटेशनल वेव या ब्लैक होल का जिक्र ही नहीं है, या सुपरनोवा का भी जिक्र नहीं है, क्योंकि उन लोगों को उसकी इंफॉर्मेशन ही नहीं थी जितनी इंफॉर्मेशन उनके पास थी. ओके, तो उसी डोमेन के अंदर उन्होंने कुछ इन्वेंशंस की, ठीक है, religions and customs, all of these. So these gravitational waves, they were detected by the LIGO observatory in USA. One observatory is in the Hanford, Washington, and the other observatory, it is in the Livington, Louisiana. And there is also one more detector, which is the Virgo. Virgo is in Europe. It is in Italy, Cassina. So Virgo is in Italy, in Cassina, and in India we are building one detector, that is the LIGO India. Okay. So this LIGO India, it will be built in the Hingoli district of Maharashtra, and it will be ready by 2024. Okay, so this LIGO India, it will be built by collaboration between the Department of Science and Technology, Department of Atomic Energy, and the National Science Foundation of USA. और जो USA के अंदर LIGO laboratories हैं, they will provide the technical support and the equipment to India. Okay, so there is a detector which is in the initial stages of construction. It is in India, in the Hingoli district, and there is one such detector that is that will come up in Japan. So why are we having so many detectors to detect the same gravitational waves? Do you see any purpose in it that we are having so many detectors? वो नींद से जाग जाओ. Yes, Subhojit. One thing is to validate the data, okay, and to obtain the data with greater accuracy. One thing is that accuracy of data, and second thing is the pinpointing the exact location of the origin of gravitational waves. Okay. So all of the network of the detectors, they will pinpoint the exact location of the cosmic event, and we can more accurately estimate the size of the black holes. Okay, so this is the main reason that even USA is providing the equipments to us. Okay. So basically, India and USA, they are very much apart, and we can say that India is on the one side of the globe and USA is on the other side of the globe. Okay. So a detector in India and a detector in USA, it will cover the larger cosmos. One side of the space is covered by India, and one side of the space it is covered by USA at the same time. So there are two LIGO detectors in USA. There is one in Europe, that is Virgo, and there is one detector in India, which is coming up by the name of India LIGO, and there is one detector which is coming up in Japan. Nikhil, which part I have to explain?
Okay.
Sir, you are telling something about neutron star. No, sir, neutron star.
Neutron stars, okay, I will come to neutron stars. Basically, by the study of the gravitational waves, we can get a lot of information about the neutron stars. Okay, I have said only this much, and we will discuss the neutron stars in detail in the coming slides. Okay. So I was telling you about the LIGO India, a gravitational wave observatory that is coming up in India, and the name of that observatory is LIGO India. And this LIGO India, it is a collaborative project, okay, between different Indian research institutes and the LIGO laboratory in USA. There are some Indian institutes, research institutes, and the LIGO laboratory in USA. They have collaborated on this project, and the government of India is providing the funding, and they have given approval to this project in the year 2016. क्योंकि 2015 में gravitational waves डिस्कवर हुई थी, and तो यूफोरिया काफी ज्यादा हाई था, इमोशंस काफी ज्यादा हाई थे, एंड इंडियन गवर्नमेंट ने फरवरी 2016 में अप्रूवल दे दिया इस प्रोजेक्ट के लिए. And then in the March 2016, an MOU was signed between the Department of Atomic Energy, which comes under the PMO, the Prime Minister's Office, and we have the Department of Science and Technology, which comes under the Ministry of Sciences. So they entered into an MOU with the United States National Science Foundation, and the institutes which are participating in the LIGO India project, they are the Directorate of Construction Services and Estate Management. Please write Directorate of Construction Services Directorate of Construction Services and Estate Management. Estate, ESTATE. Okay, Estate Management. You have to remember these names because these are participating in the LIGO India project. The first institute that is participating in this project is the Directorate of Construction Services, Construction CONSTRUCTION, Directorate of Construction Services and Estate Management. Okay, and this is located in Mumbai. And the second institute is IUCA, IUCAA, and IUCA is Inter-University Center for Astronomy and Astrophysics. Okay, for Astronomy and Astrophysics. Third institute is Institute of Plasma Research. It is the Institute of Plasma Research. And this is in Gandhinagar. Gandhinagar is in Gujarat. Institute of Plasma Research, Gandhinagar, Gujarat. And the last institute is RRCAT, Raja Ramanna Center for Advanced Technology. Raja Ramanna Center for Advanced Technology. And this RRCAT is in Indore. And Indore is in MP, Madhya Pradesh. Kritika, you have any question? Gravitational waves की detection के लिए we are creating a network of laboratories. IUCA is in Pune. IUCA is in Pune, PUNE. Okay. And the community of Indian astrophysicists, they were actively participating in the LIGO project in the USA as well. And they were very enthusiastic about the gravitational waves as well. And Indian scientists, they have contributed to the discovery of gravitational waves. And they are excited that LIGO India project, okay, one such lab will be located in India. Now, after the 2015 event, one gravitational wave was detected in September 2015. Then I think 2 more times we have detected the gravitational waves, and the strongest wave of gravity, it was detected in 2019. So that wave was detected on 21st May, was on 21st May 2019. And its data was published in September 2020. So it takes so much time to interpret this data and to publish the results accurately. They took so much of time. The wave was detected on 21st May 2019 and they published the results officially in September 2020. Okay. And the energy emitted in this event, the energy emitted was the 9 solar masses. The two black holes, they collided with each other, and they formed a black hole whose mass was 142 times the mass of the sun. Okay, and this intermediate mass black hole, it was formed by the merger of a black hole of mass 85 solar masses and a black hole of mass 66 solar masses. So there is a mass defect of 9 times the mass of the sun, and that much energy, mc square, it gets released in the form of gravitational waves, and we have detected this wave on the earth. So this is the first instance that we have observed any intermediate mass black hole. So scientists do not have any answer that how the intermediate mass black holes are existing, and further research is happening in this field. Okay, so अगर किसी को नोबेल वगैरह जीतना हो, then you can turn astrophysicist, because इस field के अंदर there is, okay, there are a lot of unsolved problems. So there is huge chance that you may get a Nobel Prize, or you may contribute to the field of astrophysics. So for the first time, we detected an intermediate mass black hole, and by the conventional theory of Einstein, they inferred that from the GTR, the intermediate black holes, they should not exist. But now an intermediate mass black hole is existing, and scientists will look for the reasons for it. Okay? Now, what are these black holes? Okay, what are these black holes? So these black holes, they are regions of space-time. Black holes are the regions of space-time, and from these regions, nothing can escape, not even light. Or in other words, the gravitational force near a black hole is so strong that even the light cannot escape it. Okay, and the center of the black hole, it contains a space-time singularity. I will explain what is this space-time singularity. You all must have observed these things, that whenever you get figures like 5/0, then what do you say? You say that it is infinity, or it is not defined. We say that it is not defined. Undefined, okay, or it is infinite. Infinite is also undefined. We say infinite because we cannot define it. Okay, we have not defined it. So these are some of the, in mathematics, these quantities, they are not defined. Okay, and defined means everything is defined by some logic, and in mathematics 5/0, it is not defined. Okay, we cannot explain what is this. Similar is the case with the space-time singularity. We say so that this is the space-time singularity because we do not know what is it. The laws of physics, they are not applicable inside a black hole. The laws of physics, they break down at the point of the black hole. Okay, and in fact, we can say that the space is infinitely curved, and that means nothing. Infinitely curved means we cannot say anything about it. Okay, because infinity in itself is not defined. We can otherwise say that the space is infinitely curved. These are the other ways of saying the same thing. सिंगुलैरिटी का सिंपल मीनिंग है जो डिफाइंड ही नहीं है, जिसके बारे में कुछ पता ही नहीं है, जिस चीज को डिस्क्राइब नहीं कर सकते तो उसके बारे में कुछ कहा ही नहीं जा सकता. Okay, the laws of physics, they break at this point, they do not apply there. The time does not exist at the center of the black hole. time and space has no meaning, because we can assign no meaning. That is why it is the space-time singularity. So a black hole is a region of singularity. Okay, and this singularity is similar to the 1/0. This quantity is not defined. We do not know what it is. Kritika, you want to say something? Something popping up in your mind? सबको समझ आया सिंगुलैरिटी से क्या मीनिंग है? वहां पे फिजिक्स के लॉज एप्लीकेबल ही नहीं है. हमको पता ही नहीं है कि ब्लैक होल के सेंटर पे कौन से फिजिकल लॉज गवर्न करते हैं नेचर को. ओके, in fact the concept of time, it does not exist at the center of the black hole. कुछ समझ आ रहा है मैं जो बातें बोल रहा हूँ? प्लीज रेस्पॉन्ड.
Okay.
Sir, for me, everything is.
At the center, Kritika, at the center of the black hole, okay, the physical laws, they do not apply there. The laws of physics, they break down at the center of the black hole. And the black holes, okay, if this is the black hole, then black hole is creating gravitational waves, and the wave is detected on the earth. But at the center of the, here the laws of physics are valid. At the center of the black hole, there is a singularity. The laws of physics, they do not apply at the center of the black hole. Okay. The scientists, they want to know the answer to these questions. Okay, even they do not know, and that is why they are excited about the gravitational waves, because they can now directly observe the black holes. This is the first, with the gravitational waves, we have the first direct detection of the black holes. इससे पहले ब्लैक होल्स को कभी डायरेक्टली ऑब्जर्व ही नहीं किया गया था, बिकॉज वहां से ना कोई लाइट आती है. इनडायरेक्ट हमको एविडेंस मिलते थे दैट ब्लैक होल्स दे एग्जिस्ट, बट फॉर द फर्स्ट टाइम वी हैड डिटेक्टेड एनी सिग्नल that is originating from the black holes. We do not know, Nitin, we do not know what is at the center of the black hole. We cannot say anything about it. Okay, this space is infinitely covered, and it is obviously infinitely covered because of the concentration of the mass density. We have nothing to explain the center of the black hole, because itself the laws of physics, they are not applicable at that point. How will we explain it? We cannot explain it. No mathematician he tries to attempt to explain 1/0. They will say you that it is not defined. Okay, this is undefined. And singularities, they are a direct outcome of the general theory of relativity. And this theory and from this theory we have some clue about these singular points. Okay, and that is from these singular points these scientists inferred the existence of the black holes. लेकिन ब्लैक होल्स को डायरेक्टली डिटेक्ट करने के लिए कोई भी तरीका हम लोगों के पास नहीं था. But black holes, they were inferred indirectly from the data that was coming from the universe, and for the first time, by detection of the gravitational waves, we have the direct evidence of the existence of black holes. So from the general theory of relativity, that theory predicted the existence of singular points, and those singular points, the scientists, they inferred them as the black holes. And in 2015, we get the first direct evidence of the black hole, because gravitational waves, they were coming from a black hole. यूपीएससी कभी नहीं पूछेंगे ये सब चीजें, थोड़ा बहुत समझ आ जाए इसलिए मैंने बता दिया। So black holes, they are of three types. One is the stellar black hole, which is a few times massive than the sun. Then the intermediate mass black holes with mass having 140, 150 solar masses, and the supermassive black hole, which is billions of times heavier than the sun. And the black holes, they are formed by the death of a star. Okay, a black hole is formed by the death of a star, and I will explain one by one. First, I will explain the white dwarf. This image is of the white dwarf star. Okay, so most of the stars, they end up becoming a white dwarf, and in the Milky Way galaxy, 97% of the stars, they will become a white dwarf. And at the end of the star life, okay, those stars which are only a few solar masses, the lighter stars, okay, the lighter stars, at the end of their life, okay, they will shed their outer layers. They will shed their outer layers without any explosion, and all the fuel, all the nuclear fuel inside the core of the star, it gets exhausted. Okay, I repeat, जितना भी फ्यूल स्टार की कोर के अंदर है वो सारा फ्यूल खत्म हो जाता है, एंड उसके बाद आउटर लेयर्स इनको स्टार शेड कर देगा, एंड फाइनली एक कोर बचती है. द कोर ऑफ द स्टार इज लेफ्ट and no fuel is burning inside the core. Okay, so the cooling process starts. Cooling start इसके बाद से होती है, and the core of the star, it will start to cool, and to get completely cool down it require billions of years. ठीक है, and because of एक हीटेड ऑब्जेक्ट जब उसको कूलिंग के लिए रखेंगे तो कुछ टाइम के लिए वो रेडिएशन एमिट करता है, and the white dwarf emit a faint radiation, a faint glow, and this is known as the white dwarf. So all these stars which are the lighter stars, which are okay, which are comparable to our sun or even less massive than our sun, they will convert to white dwarfs. ठीक है, और white dwarf कब फॉर्म होगा? when the nuclear fuel it will end. No, Nikhil, we cannot, because how will you detect it? Nikhil, we can communicate because okay, because sound waves are traveling from my side to your side. Okay, so in this space we have no atmosphere to communicate the information to us, and light is also not coming from the black holes to us. Any radiation is not coming from the black hole, so how will you detect it? Yes, we know the lighter stars, they will convert to white dwarf. And again, UPSC will not ask it. If you can remember it, that is well and good, and if you cannot remember it, एक कहानी की तरह सुन लो. ठीक है, जो भी हल्के तारे हैं, they will convert to the white dwarf. But generally, the heavier stars, the stars which is 10 to 25 times the sun, towards the end of their life, they explode and they create a supernova. Yes, Nitin, after the billions of years, the sun will become the white dwarf. It will take billions of years. They have calculated it. These scientists have calculated it using the general theory of Einstein. Because stars, they cannot fall to Earth. Why would they fall? See, gravity is because of the mass. Okay, gravity is the curvature of the space-time. If the Earth it will venture near a black hole, then the black hole it can engulf the Earth. अगर हम sun को हटा के hypothetically assume that you have removed the sun and you have put a black hole of similar mass at the center of the solar system, then nothing will happen to us. Only one thing will happen, that we will not receive any light. The Earth will keep rotating in its orbit. So I was talking about the stars which are 10 to 25 times massive than the sun. They explode in a supernova towards the end of their life. Okay, and in the explosion, their outer layer, they will blow into the space. And the core remains. Now core of the neutron star, it remains. And in this course, in this core, the fusion is not occurring. Okay, so no fusion is occurring in this core. But since this core is heavy and fusion is not occurring, so there is a outward pressure because of the fusion reaction. Because of the fusion reaction, the heat is generating, and because of the heat, there is an outward pressure. So that pressure because of the fusion, that balances the gravity. That balances the pull of the gravity. So it prevents the star from collapsing. ठीक है, जब फ्यूजन इसके अंदर से रुक जाएगा, then this pressure will end, and there is no force to counterbalance the gravity. तो gravity इस स्टार को क्रश कर देगी. ये अपनी ही gravity में it will get squeezed, and all the yes Nitin.
That force between gravity and what is that? Gravity and
Gravity. See, gravity is balanced by the fusion. Because of the fusion, there is an outward pressure. When the star was alive, the fusion reaction was happening inside the core of the star, and because of that fusion reaction, the heat was generated, and because of the heat, because of the temperature, we have an outward pressure. So that pressure was preventing the collapse of the star under the gravity. But when the star died, the fusion stopped. And when the fusion stopped, who will stop the gravity from collapsing the star? There is no one to save the star from the gravity because the fusion has ended. Okay. Then you will ask, sir, white dwarf के केस में क्रशिंग क्यों नहीं? Because white dwarf का मास कम था, तो gravity भी वहाँ पे कम थी, and that gravity was not sufficient to squeeze the star. ठीक है? न्यूट्रॉन स्टार्स के केस में मास इतना है that gravity is strong enough to squeeze the star. Okay. So इतने हाई टेम्परेचर पे जितने भी इलेक्ट्रॉन्स एंड प्रोटॉन्स हैं, लेकिन लाइटर स्टार्स न्यूट्रॉन स्टार्स इसलिए नहीं बन सकते बिकॉज लाइटर स्टार्स का मास इज लेस. Mass of the lighter stars is less, and when the mass is less, then the gravity is also less. Okay. Non-neutron stars, they are not black holes. Neutron stars are not black holes. Neutron stars are neutron stars. Black holes are different. So when the gravity will squeeze the star, okay, it will compress the star, then the electron and the proton, it will push the electron and proton into a single unit, And you all must be knowing that a neutron is formed by a combination of a proton and an electron. A neutron is formed by the combination of an electron and a proton. So because of the inward pressure of the gravity, एक इलेक्ट्रॉन एंड प्रोटॉन उसको एक साथ बांध के ग्रेविटी की फोर्स रख देगी एंड अ न्यूट्रॉन विल बी बॉर्न. एक न्यूट्रॉन का जन्म हो जाएगा एंड इनका नाम न्यूट्रॉन स्टार्स इसीलिए ही है बिकॉज दे आर फॉर्म्ड ऑफ द न्यूट्रॉन्स. ठीक है, न्यूट्रॉन स्टार्स क्यों है? क्योंकि ग्रेविटी इतनी ज्यादा स्ट्रॉन्ग है, इलेक्ट्रॉन एंड प्रोटॉन को स्क्वीज करके एक जगह पे ले आए हैं जिसकी वजह से न्यूट्रॉन फॉर्म हो गया. And for that reason, these are composed of neutrons and are known as neutron stars. अब ये collapse, अगर core का mass, if the mass of the core is between 1 to 3 times the solar mass, okay? If the mass of the core is 1 to 3 times the solar mass, so neutrons can handle that much gravity and collapse, it will stop. जब neutrons की formation हो जाएगी, then the gravity cannot squeeze the star further और एक न्यूट्रॉन स्टार का जन्म हो जाएगा. A neutron star will be born, okay, because of the intense pressure of the gravity. An electron and proton they will combine to form a neutron, and the neutron they can, okay, the gravity cannot push them further and a neutron star will be born.
Sir,
Yes, sir. Arpit? Yes, sir.
sir, I request एक बार ये sir this last 2 points is star collapse under gravity and forcing the electron and proton together into a neutron. So एक बार I request एक बार process sir.
Arpit, the neutrons they are formed by a combination of a proton and an electron. A neutron is a combination of an electron and a proton. Okay. So when they will come together, the unit will be neutron. Neutron will be a separate unit. So because of the intense gravity, electron and proton इतने close आ जाएंगे that a separate unit neutron will be formed. ठीक है, सबको पता होगा कि न्यूक्लियस के अंदर प्रोटॉन एंड प्रोटॉन एक साथ में रह लेते हैं बिकॉज स्ट्रॉन्ग न्यूक्लियर फोर्स उसको बाइंड करके रखती है. तो यहाँ पे ग्रेविटी की फोर्स एक इलेक्ट्रॉन और एक प्रोटॉन को न्यूक्लियर रेंज के अंदर ले आई और न्यूक्लियर रेंज के अंदर जैसे ही आए वो एक सिंगल स्ट्रॉन्ग फोर्स से बाइंड हो गए. अ न्यूट्रॉन विल बी फॉर्म. Neutron in electric current is very small in size. Ritika, I didn't get your question. Can you speak? We do not have neutrons in the electric current. Electric current is just the, okay, electric charges in motion in electric current. That is a different thing. Yes, Nikhil, they emit heat and light, and this is not relevant for UPSC. They will not ask you about the neutron stars. No, they will not explode under gravity. Okay, so the collapse under the gravity stops if the mass of the core is 1 to 3 times the solar mass. But if the mass of the core is more than 1 to 3 times the solar mass, then the black hole can form. The collapse, okay, the collapse of the matter under gravity, it will not stop and a black hole will be formed. And we do not know what is inside the black hole. There are only speculations, but we do not know what is inside a black hole. We have only speculation. So I told you that the collapse of the neutron star, it will stop if the mass of the core is 1 to 3 times the solar mass. Okay? And a neutron star will be born in this process. And neutron stars, they are the densest objects that have been observed. And they have been observed because the neutron stars, they can emit light and they can interact with light. So we have directly observed the neutron stars, and we have inferred that neutron stars are the densest objects ever observed in the universe. Okay, and if the core of the star, it has more mass than the 1 to 3 times the solar mass, then a black hole will be formed, because there will be no one stopping the gravity from collapsing the star indefinitely, and we do not know what is inside the black hole. There is a singularity inside the black hole. Even the general theory of relativity of Einstein, it has no answer for that singularity. It is silent. It is basically saying that this theory breaks down at the singularity, and the laws of physics, they also break down at the singularity. Kritika, please go ahead with the question. You were typing something. If the gravitational collapse is not stopping, it will produce a black hole. Neutron stars के केस में, जब neutron star की core 1 to 3 times solar masses होती है, then the neutrons, they are stiff enough, they are dense enough to prevent the collapse under the gravity. Okay, but if the mass is more, then the gravity will be more, and even the neutrons, they cannot withhold the gravity. White dwarf के केस में mass और ज़्यादा कम था. Kritika, the identity changes if the gravity is more. Okay, a black hole is different from a neutron star. You can say that a neutron star, it is composed of neutrons. What will you say about the black holes? Okay, what will you say about the black holes? You do not have any idea about what it is composed of. If you keep on compressing something, what will form out of it? Even the time has no meaning. So Subhajit is saying B. Kritika, okay, Nitin is saying B. B answer is not correct. Harini, Manju, Nupur, okay, they are saying D. Roxana is saying D. Lucky is saying D. So majority D बोल रही है. Nikhil, the question is 3 statements are given. Okay, this question was asked in UPSC 2018, and we have 3 statements. The statement 1 is light is affected by gravity. This is statement 1, and the statement 2 is the universe is constantly expanding. Okay, second statement is universe is constantly expanding, and the third statement is matter warps its surrounding space-time. Third statement, I repeat, matter warps its surrounding space-time. Then the question is that which of the above predictions of the Albert Einstein general theory of relativity, okay, often discussed in media are correct. ये जो 3 statement है, इनमें से कौन सा statement correct है? Okay, Nikhil. So the correct answer for this question is D. All the statements are correct. अभी देखो UPSC ज़्यादा tough questions नहीं पूछेगी, because they are not framing the question for the astrophysicist. They are framing. Nikhil, all the statements are correct. Even the statement 1 is also correct. Light is affected by gravity. Light is affected by gravity. That is why the black hole, okay, it prevents the escape of the light. Gravity effect, because gravity is the curvature of the space, and the light will also follow the curvature of the space.
If light is affected by gravity, then why can't gravity overtake on light, sir?
Why can't?
Gravity over, you told that there is balance between this nuclear fusion and this gravity, no, sir? Then why can't gravity overtake on nuclear?
The outward pressure, because of the thermal energy, okay, that was preventing the collapse under the gravity. But light is basically composed of the photons. Light cannot escape the black hole because the curvature of the space is such that it cannot escape it. Light has to follow the curvature of the space. Yes, Kritika, light is affected by the gravity. If the space is curved, what the light will do? It will follow the curvature. Okay, Kritika, light is also affected by gravity. And that is the precise reason that from the black hole, the light cannot escape. The universe is constantly expanding. This is observational data from the Hubble Space Telescope, and ये भी news के अंदर आता रहता है. And the matter, it warps the surrounding space-time. This statement is also correct. So Vijit, you are saying that light, because light is both a particle and light is wave, so that is the reason that gravity is affecting it. No, Subodhi, because gravity is not a force. Okay, gravity in the Einstein chain, the GTR, it is related to the curvature of the space. And if the space is curved, okay, you will automatically follow the curvature of the space. It is related to the geometry of the space. Gravity is not a force. Gravity is not a force in the GTR. It is related to the curvature of the space. And near a black hole, the space is infinitely curved. We do not know how much curved it is, and that is why we are saying it is infinitely curved, because we do not know. So I think this question को देख के थोड़ा confidence आया होगा that UPSC, it does not ask the difficult questions, and so all the questions that can be framed regarding this gravitational waves, okay, they can be easily answered from whatever I have taught you. Okay. So now we have spoken enough about the larger cosmos. Okay, we have discussed the cosmic scales, the scale, the distances, okay, जिनको light भी 1.3 billion years में travel कर रही है. Now we will discuss about the distances that are as small as 10 to the power minus 15 meter. Okay, so this is the 1 million times the nanometer. 1 million times the nanometer. So particle physics, it is concerned about the small scale physics. Okay, what is happening at the subatomic level, at the level of the electron, and even what is happening inside a neutron. Okay, so we are inspecting all these questions. What are the laws of nature that are governing the motion of a electron, the motion of a proton? Okay, the motion of an electron and proton inside a neutron. Okay, what is happening inside the nucleus? So all these questions, they are answered under the domain of particle physics. और यहाँ पे भी हम इसको study इसलिए कर रहे हैं so that we can know about the structure of the universe. Because the whole universe, it is composed of these, okay, these fundamental particles like the electron. Okay, we have other particles like proton, neutron. So all the universe is made up of these particles. Okay, the atom is not a fundamental unit because atom is composed of several other entities. And on the right side of this slide, there is, we have written very elaborate equation, and it is precisely this equation which explains the particle behavior at the subatomic level. ठीक है, तो जो physicists, जो particle physicists जिन equations को read करते हैं, they look something like this. Okay, so theoretical predictions, they arise from equations like this. This equation and this equation is the same. क्योंकि लास्ट क्लास में किसी ने पूछा था कि सर सुपरनोवा से लाइट आई तो उससे कैसे पता चला that universe is expanding. There are equations like this in case of GTR also. In the general theory, we have equation like this. Okay, and from those equations we infer something. So we collect data from the space and we predict some things from those equations. So these are very elaborate equations, and these are different disciplines. Okay, the dedicated scientists, they are studying these and they are predicting something from the theory, and they are doing the experiment. They are matching the result from the experiment with the predictions of the theory. Okay, so इसको भी ये कुछ याद नहीं रखना है, सिर्फ बताया है that theory और experiment को reconcile कैसे करते हैं. यहाँ पे तो सिर्फ जो मोटे-मोटे रिजल्ट हैं वो हम बता देते हैं. ओके, सो सबने नाम सुना होगा सर्ल, द लार्ज हैड्रॉन कोलाइडर, सर्ल. ओके, LHC. Ritika, you are writing something. So this CERN, this organization and this lab, Large Hadron Collider, these labs, they test the predictions of this equation. This equation describes the particle physics, and the lab CERN, Large Hadron Collider, they test the predictions of the particle physics. Okay, particle physics को टेस्ट करने के लिए एक लैब बनाई हुई है, that is the CERN, Large Hadron Collider. and इसी एक्सपेरिमेंट में हमको हिग्स बोसॉन की डिस्कवरी हुई थी. मैं जल्दी से बताता हूँ व्हाट वाज दिस हिग्स बोसॉन. सो ये हिग्स बोसॉन पार्टिकल फिजिक्स ने इसके एग्जिस्टेंस को बताया था कि that there should be a Higgs boson that was predicted from the particle physics, but we have never observed the Higgs boson. और थ्योरी के अकॉर्डिंग कुछ स्पेसिफिक कंडीशंस के अंदर ही हिग्स बोसॉन को प्रोड्यूस किया जा सकता है. तो वो एक्सपेरिमेंट्स किए गए थे सर्न के अंदर, एंड फाइनली इन द ईयर 2012 the scientists, they discovered the existence of Higgs boson. तो वहां से कंफर्म हो गया that the particle physics is very valid. Okay, the model given by the particle physics, it was very valid because Higgs boson was a prediction of the particle physics, and scientists, they were discovering this particle, the Higgs boson, that was predicted by the theory. ठीक है, फिजिक्स ने प्रेडिक्ट किया था कि ऐसे एक पार्टिकल की एग्जिस्टेंस होनी है, एंड उस पार्टिकल को डिस्कवर किया गया एक्सपेरिमेंटली इन लार्ज हैड्रॉन कोलाइडर. आई थिंक कुछ ज्यादा तो हैवी बात नहीं बोली यहाँ पे, सबको समझ आया. मैथमेटिकल थ्योरी एक फिजिकल थ्योरी. ओके, फिजिक्स से हमने कुछ प्रेडिक्शंस किए थे, लेकिन प्रेडिक्शंस को टेस्ट करना पड़ेगा, और वो प्रेडिक्शन हमने लार्ज हैड्रॉन कोलाइडर में वहां पे उनको चेक किया गया, और फिजिक्स कहती थी कि हिग्स बोसॉन को एग्जिस्ट करना चाहिए, और साइंटिस्ट ने उसको रियल में प्रोड्यूस करके दिखा दिया दैट हिग्स बोसॉन इट एग्जिस्ट इन रियलिटी. तो पार्टिकल फिजिक्स क्या करती है? पार्टिकल फिजिक्स it studies the interaction between the subatomic particles. जो भी हमारे फंडामेंटल पार्टिकल्स हैं, जिन पार्टिकल्स से मिलके पूरा ब्रह्मांड बना है, the universe which is composed of these subatomic particles. So in the particle physics, we are interested in the interaction between any two particles A and B. और इनके अकॉर्डिंग there are only 4 forces in the universe. Okay, one force is the gravity, the force of gravity. Gravity is because of mass. Okay, and the gravity, it has the infinite range. Because the gravity has the infinite range, so we are rotating around the sun. Because sun can exert force on us even 150 million kilometers away. And out of all the fundamental forces, the gravity, it is the weakest forces. So any two matter particle, if they have mass, they will also interact by the force of gravity. One thing. Then also in nature, we have one force which is the weak nuclear force. Okay, and this weak nuclear force, this is also a short range force, also known as weak interaction. जैसे आपने स्टडी किए होंगे अल्फा बीटा एंड गामा डीके. So in these decays we have the weak forces in operation. Then we have the electromagnetic interaction. This is the stronger force, and this also have the infinite range. Okay, electricity and magnetism. Magnets से सब खेले हैं. So the force of magnet is okay, it is strong, and the range is also infinite. Then we have the strong nuclear forces. They operate inside the nucleus. They have short range and they are the strongest. They can even bind a proton and proton together. So this is all for today. We will continue from here tomorrow. And यहाँ पे कुछ नहीं बताया, बस ये बताया कि there are 4 fundamental forces in nature. इनके सिवा यूनिवर्स में अभी कोई फोर्स नहीं है. कोई भी इंटरेक्शन हो रहा है, if you are feeling a sunburn because of the UV rays. UV rays क्या है? These are the electromagnetic rays. And UV rays, they are interacting with the material in your skin. So this is also an electromagnetic interaction. UV rays तुम्हारे molecules को जाके damage कर देंगे. So that is also. Thank you, Palak. So this is all for today, and we will continue the particle physics tomorrow.